Hi, so today I'm going to be reviewing graphing a quadratic function that is in vertex form. So here we've got a quadratic. It is in vertex form because it is in the form y equals a, x minus h squared plus k. So it can say y equals, or it could say f of x equals, okay? All right, so the first thing I like to do is actually determine if it opens up or down, because I kind of want a picture of the parabola in my mind. So we know that the graph of a quadratic function is a parabola, and we know that if a is positive, it opens up. If a is negative, it opens down. So I know that this is positive. It's going to look something like this. Because it's vertex form, that means I can see the vertex very clearly as a constant in the equation. The vertex is h comma k. So in this case, it would be 3, 1. Now notice that this minus 3, it's kind of like, if you think about it, like the opposite sign, but the k has the same sign. So my vertex, so the bottom, the minimum of the graph is at 3, 1. All right, if I want to find the x-intercepts, well, just like any x-intercept, we set y equal to 0. We set y equal to 0 and solve. All right, so let's see what we get. First thing I'm going to do is I'm going to subtract 1 to both sides. And I get 2x minus 3 squared equals negative 1. And then I'm going to divide by 2. And I get negative 1/2. So I have x minus 3 equals, or squared, equals negative 1/2. Yuck. Because now I have to take the square root of both sides. Now, I've taken the square root of both sides, so I'm going to come up over here, and I've got the square root of a negative, so I have x minus 3 equals plus or minus I, because I've got to take out that negative, and then I have the square root of 1, which is 1 all over root 2. Now, I have to rationalize that, so that's going to give me root 2 over root 2. So now I have x minus 3 equals 1 times I is I, so plus or minus I root 2 over 2. All right, and then I bring the 3 over, so so I'm going to add 3, sorry. I'm going to add 3 to both sides, and that's going to give me x equals, I always put the 3 in front of the plus minus, so 3 plus or minus I root 2 over 2. Sorry, I ran out of space there. Okay, so these are imaginary roots. So remember, if there's imaginary roots, it means it's not going to cross the x-axis. So I'm going to have to use my axis of symmetry and my y-intercept and reflection point. So my axis of symmetry is the line that goes down the vertex. So if I have this vertex at 3, 1, so 1, 2, 3, 1, I know it opens up. I kind of knew that it was going to have imaginary roots just because of that. There's a vertical line, it's like a mirror that goes through the graph right here. Well, since it's a vertical line, it's going to have the equation x equals, and it will always be the x coordinate of the vertex, which in this case was 3. So x equals 3. All right, but now that y-intercept and that corresponding point are going to be really important. So to find the y-intercept here, I'll rewrite it here. 2x minus 3 squared plus 1. I'm going to say y equals. All right, to find the y-intercept, we let x be 0 and solve for y. All right, so let's see what that's going to give us. So we get y equals 2. So 0 minus 3 is negative 3 squared plus 1. Negative 3 squared is 9. 9 times 2 is 18 plus 1 is 19. Okay. So y equals 19. So the point 0, 19, so it's going to be way up here. 0, 19 is on my graph. And if I reflect that over the axis of symmetry, it has to be the same distance away. So it's 1, 2, 3 to get over. 1, 2, 3. So I've got to go 3 in the other direction. 1, 2, 3, which is going to put me at 6, 19. So I have 0, 19 as my y-intercept and 6, 19 as my other point. And so I can then, sorry about that, draw my parabola. Okay, so that is actually what you go through in order to find the graph of a quadratic from vertex form. Now, you could, if you wanted to, get some more points on the graph. You could just make a table of values. Make an XY table, plug in X's, and get some Y's. That's another way to get some additional points on the graph should you want them. All right, hopefully that was helpful. Have a great day.